Hi, today I'll be talking about how to solve quadratic equations using three different methods, which are vertex form, standard form, and your graphing calculator as well as a bonus tutorial for piecewise functions. If a function is in vertex form, then we can typically determine its transformations and graph them without any additional calculations. Transformations change the position or size of a figure. They can be applied to parent functions too. For example, for quadratics, using the vertex form, fx equals a times bracket x minus h close bracket squared plus k, where h and k are the vertex. We can use this information to complete this question without any additional calculations. We will first identify the vertex. In this case, the 4 inside the brackets is going to become negative because during calculation, when we zero out the brackets to find the vertex, the 4 is brought over to the other side, becoming negative. Next, the k, or the y-coordinate, will be 0. Since there is no k, the vertex is -4 and 0. Now that you have the vertex, you can simply plot the next points by numbering up and down on a table. It is a negative slope, so it'll face down. The standard form of a quadratic equation is f of x equals ax squared plus bx plus c. It creates a U-shaped curve called a parabola. To accurately graph a parabola, we need to identify the axis of symmetry, or the x-coordinate, and the corresponding y-coordinate to find the vertex. For example, in questions fx equals x squared minus 6x plus 11, we need to identify the axis of symmetry. We will use the formula x equals -b divided by 2a. In this case, b is -6, a is 1. So it is negative times -6 divided by 2 times 1, which is equals to 3. Now plug 3 into the original function to get the corresponding y-coordinate. So the vertex is 3, 2. But to graph the rest of the graph, we can't just add the slope like in absolute values, since quadratics change at a constant rate. So you need to number up the x-coordinate and plug it into the original function to get the y-coordinate. You could also use the graphing calculator to help graph your functions. For example, in questions, fx equals x squared plus 2x minus 5. To correctly view this function on a graph, first turn on your graphing calculator by pressing AC. Now, go to Menu, select Graph, and press Execute. Enter x squared plus 2x minus 5. And double-click on Execute. Now we can see our function on a graph. To find the minimum or maximum, press F1 to trace. It is 1, 6. For questions with absolute values like fx equals 2 divided by 3 absolute value, x plus 1 close absolute value minus 1, press exit to exit from the graph, and F2 and F1 to delete the previous formula. Enter the fraction by pressing the fraction button on the calculator. To get an absolute value, you need to press Options and select and go to press F5 to scroll. Press F1 for abs. Now type everything in and out the absolute value. And press execute. A piecewise function is a function built from pieces of different functions over different intervals. For example, in this question, x4 is where both functions start. So let's mark it with a dotted line. Plug 4 into -3 divided by 2 absolute value x plus 5 to find its y-coordinate on x4. And find the vertex using the previous method of identifying the vertex form. The h is 0 and the k is +5, so it's 0, 5. Measure out the rest of the function using the slope. For -2x plus 3, plug in 4 in the function to get the y-coordinate for x4, which is -5. To find the next point, so we are able to draw a line, plug in x5 to the function, which will be -7. Draw your line. Make sure to mark the points on the dotted line with the correct open circles and closed circles.